Hey guys, Travis Gillespie here. We've been looking at probability, and in this section we're going to look at counting methods, also sample spaces. Let's go to counting methods real quick. It sounds pretty simple, and you might be thinking, boy oh boy, I've been doing this since elementary, and if you think about counting, it's just basically 1, 2, 3, 4, 5, and so on and so on. It's pretty simple. But counting methods, as math gets more complicated, the counting methods can get more complicated as well. So there's a whole division of math that deals with counting methods, and it's called combinatorics. Let's just do a little arrow down here and write that word down, combinatorics. C-O-M-B-I-N-A-T-O-R-I-C-S. And if you're interested in it, go and take a look. But let's move on to what sample spaces are. When we're dealing with probability, sample spaces help us to find out the values or they help us to find that probability. And a sample space, it's when you run an experiment, it's pretty much all of the possible outcomes. So what I'm going to do here is right next to sample spaces, do a little arrow. Sample spaces are all of your possible outcomes, so all of the outcomes. So let's read through this first problem and see what we can do to solve it. Okay, so it says Matt wanted to take a 3-day weekend trip to visit his grandparents. He can take either Friday or Monday off from work, and he can either fly, drive, take a train, or take a bus. How many options are available to Matt? I'm going to highlight a few of the key important words in this problem. So the first thing I want to do is just look at that first sentence. It says Matt wants to take a 3-day weekend. So I'm going to just highlight 3-day weekend here. He can either take Friday or he can take Monday off. Also, he can either fly, drive, take a train, or a bus. And then this last question, this last sentence here, it's asking us how many options are available to Matt. So let's just backtrack for a second. Earlier I was saying that we use counting methods to help us with probability. And counting methods are a part of this word, the division of math, combinatorics. Well, when you hear that word combinatorics, what are you thinking? In our daily lives, you use combinatorics every single day, and you might not even think about it. So let's just think of a couple of options real quick. Well, if you're waking up and going to school or going to work, you're going to probably create a lunch, or you might buy a lunch later in the day, but you're going to combine certain foods that will go well together, such as peanut butter, jelly, and bread. So those are different combinations. We might actually want to take a turkey sandwich with lettuce. So you're combining different materials for your food. Or maybe you might want to wear different types of clothes or different color coordinate your clothes or different patterns or different materials for your clothes if you're going to get dressed for work or school. Now, when you go to school, you might have a combination to opening up your locker. Or when you get home from work or home from school, you might have a passcode that you have to type in a certain combination of values to turn off an alarm in your house. So there's all these different types of combinations that we use in our daily lives. And Matt's using a set of combinations here to plan a trip to see his grandparents. So let's take a look at how we can figure out all of the different types of options that are available to him. But when you hear this word options, and I want you to think of that word instead of combinatorics, just think the word combinations, and let's write that down below. So when you hear the word options, think of combinations. And when you're combining things in math, one of the operations I want you to think of is multiplication. So I'm just going to put a multiplication symbol below. So if you're making combinations, think about multiplication. If you see that word options and you're dealing with combining different things together, think about multiplication if that word options is there instead of the word combinations. So let's break this problem apart even further. Let's just talk about the different days that Matt can take off. Well, he's going to take a 3-day weekend. So the first thing I want to do here is write down how many different types of 3-day weekends he could have. Well, he could have, let's write that word down, 3-day weekends here, 3-day weekends. And his first 3-day weekend he could have, well, he could take Friday off, and that means he would have Friday, Saturday, and Sunday off. Let's write that down. Friday through Sunday off. So he would leave Friday, come back Sunday. That's one 3-day weekend right there. The other type of 3-day weekend, well, he wouldn't take Friday off. He would have to take Saturday off, he would have Sunday off, and then Monday off. So that's the other 3-day weekend, that Monday portion right there. Let's go and write that over off to the side. So we could have Saturday, Sunday, so Saturday through Monday off. And I'm just going to write MON here, so Saturday through Monday. So this is a second 3-day weekend. It looks like there's 1, 2, 3-day weekends that Matt could have. So I'm going to just write that number 2 here. There are 2 3-day weekends. I'm going to go back and change my pen color. Okay, so from here, let's look at the different methods of travel that Matt could choose from. Matt can choose to fly, drive, take a train, or take a bus. So if he left on Friday through Sunday, he could fly, he could choose to drive, he could take a train, or he could take a bus. All right, so these are the 4 different methods of travel. So there are 4 methods of travel. Let's go ahead and write that down as well. I'm going to put a 4 down here. And let's actually connect this, this 3-day weekend with each different type of method of travel here. So he could take Friday through Sunday off and fly, or he could take Friday through Sunday off and drive, or he could take Friday through Sunday off and take a train, or take Friday through Sunday off and take a bus. So these are 4 different ways of traveling for his 3-day weekend if he were to take Friday through Sunday off. However, he has another option over here. He could take Saturday through Monday off and take the same methods of travel. So I'm going to just repeat what I wrote before. F for fly, D for drive, T for train, and a big B for bus. All right, and let's go and connect those as well. So here's if he did not take this 3-day weekend off, and he chose Saturday through Monday as his 3-day weekend, well, here's another option for him. So we have 1, 2, 3, 4 options, a 5th option, a 6th option, a 7th option, and finally an 8th option that Matt could take for his 3-day weekend. So right now what we see here is that there are 8 options available. So Matt has 8 options for his 3-day weekend. And the way I prove that right now is this information, what we created right here, was a tree diagram. So let's just write that down. This is a tree diagram. So this is the tree diagram that was created to find the 8 options. But earlier I told you if you see that word options or that word combinations, I want you to think of multiplying information together. Think of multiplication. Well, how can we take this tree diagram or the information in this tree diagram and multiply it together to get 8 options? Well, simple. Let's go back over to the left side of the screen. We've already broken it up into 2 different options of a 3-day weekend and 4 different options for methods of travel. So let's take 2 and multiply it by 4. When you do that, the value you get, 2 times 4, gives you a value of 8. So there are 8 options available to Matt still. So regardless, if you choose to draw a model, such as using a tree diagram, or you choose to multiply the 2 values together, you should come out to get the same answer. And I just want to make one more note here. If we're looking at the tree diagram, this is the sample space below. These are all the possible outcomes that we could have.